Hello, quarantine sixth graders, and welcome to day 10 of distance learning. This is your final bit of introduction to chapter 3, lesson 1. There was just a lot to present, and there's a lot of information to take in. So let's go ahead and begin. We'll make this nice, short, and sweet because we have some other things to talk about. And I forgot to turn off my notifications. Oh, you're going to hear some minging. Okay, so. Our fifth and final clue for mineral property is the property of cleavage or fracture. Um, the arrangement of atoms, so crystal structure, is going to determine if a rock or mineral cleaves. The word cleave means to break open along a smooth, flat plane or smooth, flat surface. So, where a mineral is going to split open, if it's very smooth and flat, we call that cleaving or cleavage. If, however, when the mineral splits open, it is very uneven, rough, or jagged, we call that fracture. Now, to give you an idea of real life, this is a type of knife called a cleaver. It is designed to split open things along a smooth, flat surface, which is why it's such a long, tall blade. Here we have a cleaved cupcake. It's been split open and is pretty smooth along the where it broke apart. And for those of you who ever watched the Lord of the Rings or the Hobbit trilogy movies, there was an actual sword called the Goblin Cleaver because it split open goblins along smooth, flat surfaces. Now, minerals will cleave in either one, two, or three directions, or zero directions. Sometimes they're at 90-degree angles, sometimes they are at odd angles. So muscovite mica has 1 degree or one plane or one direction or one dimension. There's a lot of ways of saying it. One direction of cleaving. So it will split open along smooth, flat surfaces. It's kind of cool because you can actually just kind of peel apart this mineral one layer at a time. Something like feldspar will cleave in two directions but fracture in the third. So there's two flat surfaces that are 90 degrees to each other, and the third one will be kind of rough and smooth, or rough along it. Halite will cleave in three directions. It's actually kind of fun. I think there's a YouTube video out there of somebody cleaving halite, and all they do is they just smack it with a hammer, and it breaks open into smaller cubes, just because of the way it splits open. Something like calcite will cleave in two directions, but in not 90-degree angles. So really, it comes down to how the molecules arrange themselves in their repeating pattern, their crystal structure, their orderly arrangement of atoms, and that's going to determine the angles at which they cleave and the how many cleavage directions there's going to be. There's all kinds of fancy diagrams that we don't have to be aware of, but I just wanted to make you aware. So if we look here, these are very kind of weak bonds, and so that's where a mineral is going to kind of cleave open. Here's a mineral called tobermorite, and here is its cleavage plane. These bonds between these atoms are weaker than the bonds between here. So if the mineral has pressure applied to it, it will split open here and be very smooth and flat. If you try to split it open this way, these bonds are a lot stronger and the mineral will not cleave in that direction. It will fracture in that direction. So I just want to make you aware that the mineral's crystal structure and its composition have a lot to do with how it will split open when, well, hit by something. So here it, again, is another example of muscovite mica. It is peeling off in smooth, flat surfaces, one layer at a time. It's a fun mineral if you ever get a sample of it, because you can just peel one layer at a time until it's all completely separated. It's honestly a little satisfying. Feldspar, as you can see, has two directions of smooth, flat surfaces, but because of its crystal structure, This third direction, you can see here is the kind of like the parallel version of it. This third direction is fracture. It's very uneven, it's rough, it's jagged. So feldspar would have two directions of cleavage, one direction of fracture. Calcite is going to be cleaving in three directions. And then something like quartz is going to have no directions of cleavage. There's its crystal structure is such that no matter how you hit it from any angle, it will always break open along a along a rough and jagged surface. And so fracture quartz has only fracture, no directions of cleavage. And then a fun one that you'll see from time to time is something called conchoidal. This is a mineral that was hit by a hammer, and it breaks off on these like semicircle rings. It almost looks like a seashell, and so that's called conchoidal fracture. So that it kind of wraps up our properties. When a geologist is presented with an unknown mineral, they have to do a lot of questioning and a lot of scientific tests. And then each one that is going to reveal a little piece of information or a clue, and that's going to eventually narrow it down to just one possibility. So they will ask, what is the hardness? What is the color? What is the streak? Or what color is the streak? Color, we don't use color. What is the luster? What is the specific gravity or the density? And then the cleavage and fracture. Now, one of two things is going to happen. We will go from over 2,000 possibilities down to just one possibility, and now you've identified the mineral. Or option number two, you narrow it down to zero possibilities. There is no mineral that matches all of these criterias all at the same time. And that means that you have discovered a new mineral. And that's pretty awesome because usually you get to name it. I think bogdanite has a nice name for a new mineral. All right. We need to talk about next week, and in fact, the rest of the next several weeks. The district, not just Green School, not just the blue team, the district is changing our weekly structure. So instead of a little bit of every subject a day, you're now going to be focusing on two subjects per day. So we'll show you what this looks like in a little bit. But instead of going on 4 subjects a day, now you're going to go down to 2 subjects a day and just a little bit longer for each one. So for next week, now that we're finally done with the introduction, we're going to go and read and do the book work. Now, the book, this section is from pages 88 to 99. This is going to be broken into 2 parts. So we're going to do half, a little bit more than half on Monday. And then Tuesday, we don't have science. And then on Wednesday, you'll do the other half. And then to check your book work, I'm going to have some review questions at the end, kind of like what I've been doing for the last 10 days. Let's take a look at next week's Blue Team Weekly Guide. So, your weekly guide now is going to start by having all of your subjects, and this is going to be like one giant launch pad. So if you look at Monday, Monday is set aside for math and science. That's all we want you to work on Mondays, just math and science. If you have Miss Hallquist, there's her assignments. Miss Coleman is you can click here and go to her weekly guide, and Miss Ryan's going to have hers. Here's my activity. It's going to be week 3, part 1, and you just click that. Tuesday, if you look at the Blue Team Weekly Guide, is set aside for language arts and social studies. If you have Miss Fox or Ryan, you'll use this as your starting point. And social studies, Mrs. Walters adding in your activities here. Also, I forgot to mention this, you now are going to start having information or activities from your specials teachers, your gym, your art, your music, things like that. Now, all of them are going to be posting, I think, to Blackboard. So on Monday, you're going to go to your A-Day special teachers' Blackboard sites and click around and see what they want you to do. On Tuesday, you'll go to your B Day, specials teachers, and see what they have for you on Blackboard. Wednesday, we're back to math and science. So here's week 3, part 2, and I'll have a link there for you. And then on C Day, because it's a C Day, well, I don't know if it is a C Day, but you'll go to your C Day specials on Wednesday. All right. Thursday, back to language, arts, and science, and then D Day. And then Friday is, this upcoming Friday, it was supposed to be a normal day off. And so you're not going to have, you're going to treat it like a normal day off from school. Normally on Fridays, that's just a catch-up day where you go back and you make up anything that you need to. And that's how every week's going to kind of work for a while. Mondays and Wednesdays will be math and science. Tuesdays and Thursdays will be language, arts, and social studies. And then you'll go through your specials classes throughout the week. So for Monday next week, here's your week 3 part 1 activity, which for me right now, I'm still putting it together, looks like this. You'll be able to start clicking through here and kind of treating it like normal. But we're going to read chapter 3, lesson 1. We're going to stop on page 95 on Monday. And then here's your spot to ask me questions. And then here's my follow-up questions. So when you go to, when you're done with the book work, you're going to answer some questions about the book work that I'll have figured out for you later. All right, so that is what is next week's going to look like. We look forward to seeing your work. Bye-bye.